Okay, today we'll look at solving a system of quadratic inequalities or solving quadratic inequalities. We have solved linear inequalities. Today we'll solve quadratic inequalities. In order to solve these quadratic inequalities, we need to solve a system of two equations by graphing. The nice thing about these problems is that you do get to use decimals, and if you have them on the test, you get to use decimals as well. Okay, so here we have an inequality, and we're saying x. When is it? What value of x is x squared plus 8x plus 20 greater than or equal to 5? What value of x is that? Is true? What value of x makes that true? Okay, I mean, I can just start with just guessing, like what happens if x is equal to 0. So I'd have 0 squared, so I would have 0 squared plus 8 times 0 plus 20, and that would be 20, and certainly that would be greater than or equal to 5. Okay, but the easiest thing to do is just to graph it, and then interpret the graph. So I went out to decimals and I graphed x squared plus 8x plus 20 and y is equal to 5. And there are my two graphs. I have a parabola and I have a linear equation. Okay, so what we're asking, okay, when is that parabola that I highlighted in yellow, when is that above, and I'll just leave it like this, when is that above the line y is equal to 5? So that's this line here. Right? So this is the line y is equal to 5. All along here are my x values, and this is the equation y is equal to x squared plus 8x plus 20. So when is that parabola? When are the y values for that parabola that I highlighted in yellow greater than the y value for 5? Well, it's anywhere, so from -3 to infinity, okay, on this side. So from -3 to infinity, the y value is always greater than 5. And likewise, for any value of x from -5 to infinity, the y value is always greater. Okay, the y value is always greater. So the solution to this, oh, and just remember, I tested the point 0 for x, and 0 certainly would be, well, that would be over here somewhere. That was, let me see, this is going by -3, -2, -1, so this is the point x is equal to 0. Okay, and when x is 0, you get 20, so way up there. Okay, but you'll see, you get a point way up there somewhere. When x is 0, you'd get 20. You get a point, but that would be above the line y is equal to 5. So we would say then that the solution to this, my solution set, as long as x, so x is going all the way to -infinity here. So as long as x is going from -infinity to -5, close because it's equal, that parabola, that yellow line, will be above the line y is equal to 5, or union symbol, or, as long as x is less than or greater than or equal to -3, because we're going that way to infinity. All right, so that would be my solution, an interval notation. Or I could say as long as x is greater than or equal to -3, or x is less than or equal to -5. That parabola, the y values for that yellow line will be above the y value, y is equal to 5. Then they did that in interval notation for you. Oops. I don't know why this thing doesn't like grabbing it when I want it there. Okay, so there. Pretty easy to do by graphing. Interpretation, though, sometimes students have difficulty with that. Keep in mind we're working with the x values to determine the interval, but we need to look at the y values. Okay, we express our answer in terms of x values, but we need to look at the y values to make that determination. We have to look at the y values. So let's look at the next one. Now what happens, so this one was greater than or equal to 5, what happens if I say now less than or equal to 5? So again, I'm asking, when are the y values for that quadratic, that yellow line, less than or equal to the y values? Y is equal to 5. So that's y is equal to 5. Well, you can see that that parabola that I highlighted in yellow is always less than or equal. The y values are always less than or equal between the x values, -5 and -3. Always less than. All right, so let me get rid of that. Always less than. So, as if I write that as an inequality, that would be x is less than or equal to -3 and greater than or equal to -5. And we're on, okay, the y value, so in between there. The y value will always be less than the green value for the x values between and including -3 and -5. And then the interval notation, it would be, so -5 closed, -3 closed. -3 closed. Okay. All right, the next one here. So the first two cases we had the leading coefficient x squared was positive. Okay, positive x squared. When it's negative, it kind of like things flip over. They flip around. So you'll see what I mean. So that was greater than or equal to 5, and so we had like an or. They were on the outside. The solutions were on the outside. When I had less than or equal to 5, the solutions were in the inside. Now, when we have a negative leading coefficient, things will switch around. You'll see what I mean. All right, so let's look at this one. Example, -2x squared plus 3x plus 7 is less than or equal to 2. Again, I still wrote two equations here. One is y is equal to -2x squared plus 3x plus 7, and the other one y is equal to 2. And let me go out here and graph it. Well, okay, so I just went out and graphed it, and you know, like I did before, and I got the x value. I got the coordinate point -1 and 2 and 2.5 and 2 on decimals. So let me do that. Okay, so let me just delete that. And so what did we have? Y equals -2x caret key raised plus 3x plus 7. And then y equals 2. Okay, and so that's the picture I got. And so with this one here, we're asking, when is that parabola less than or equal to the line y is equal to 2? Well, this is the line y is equal to 2 there. So when are the y values for that parabola less than or equal to the line y is equal to 2? Well, it's any x value that, as long as x is less than or equal to -1 or greater than or equal to 2.5, okay, the y value for the parabola will always be less than the y value y is equal to 2. As x goes to positive infinity or x goes to negative infinity, the y value on that parabola will always be below the line y is equal to 2. See, I told you things are going to flip around. Right? Didn't believe me? Let's see here. So when we said less than, you see it was between 2 points. Okay, now when we say less than and the leading coefficient is negative, it's going to be outside of 2 points. So things flip around. So here, so my solution, so as an inequality, it would be x is greater than or equal to 2.5 or x x is less than or equal to -1. In interval notation, it would be from -infinity to -1 closed, or from 2.5 to infinity. Again, the y value for the parabola is always less than or equal to the line y is equal to 2. as long as x is greater than or equal to 2.5 or x is less than or equal to -1. And in the final case, what happens if we flip that inequality around? So we say negative 2x squared plus 3x plus 7 is greater than or equal to 2. Oops, I guess I better write my other inequality. So y equals, or 2x squared plus 3x plus 7. What happened to my two equations? Did I have two equations? Yes, so let me just see here. Oh, come on. Yeah, I had those puppies. Yeah, they were there. All right, so there. Somehow that one got erased. All right, so here, what we're asking, hey, so this is the line y is equal to 2, right there. Oops, I want the green because it's green up there. So this is the line y is equal to 2. And we're saying, hey, when is that quadratic above that green line? So I'm going to highlight it. Right there. Well, what are those x values? Well, those are x values anywhere between -1 and 2.5. X values. That parabola, the y value will always be above the line y is equal to 2. So, solution. So as long as x is less than or equal to 2.5 or greater than or equal to -1. Okay, the y value for that parabola, the yellow line, is always greater than the y value, y is equal to 2. And then in interval notation, it would be from -1 to 2.5. Okay, so pretty easy. Those are the 4 cases. You only have those 4 cases when graphing. So interpret correctly, graph using Desmos, and you should not have a problem. All right, and now I'll review with you some complex number operations because you guys will have a test. Oh, we have one more section to do. And then we will be done. So we'll probably be done tomorrow. Okay. And then we can review 2 days. And then you'll take your test. All right, okay, so to review, adding complex numbers, you have the real part and the imaginary part. So if I have -2 plus 4i, and then I'm going to subtract 5 plus 8i. Well, I'm not adding, I'm subtracting, but we'll change subtraction to addition. We have to distribute that negative, right? So this is going to be plus -5 minus 8i. Okay, and so we have -2 plus 4i. We add the real part, and then we add the imaginary part. Pretty easy to do. So we have -2 plus -5 plus 4i minus 8i, and then that will give us -7, -7 minus 4i. Complex number form, real part, imaginary part. Remember, real part comes first, and then the imaginary part. Oh, and on the test, guys, make sure you write it that way, because we say write it in complex number form. So that was adding or subtracting. They're all one and the same. All right, and then multiplying. So if I have 2i times 3 minus 5i, we have to distribute the 2i. So 2i times 3, that will be 6i. And then 2i times a -5i, that would be -10i squared. But remember, I squared is equal to what? -1. I squared is equal to -1. So we have 6i minus 10 times -1, which is just 6i plus 10. But that's a no-no. We write the real part first, followed by the imaginary part. And final answer. Okay, so there's your answer there. Pretty easy. Distribute. And then the last one was when you had to FOIL. So for example, if you have 7 plus 2i, and you're going to multiply that by 5 minus 3i, just made up one. So you FOIL. 7 times 5 is 35. 7 times -3i is minus 21i. 21i, and then 2i times 5 is 10i. And then 2i times negative 3i is a minus 6i squared. Remember, I squared equals negative 1. So what I have, 35 minus 11i, and then minus 6 times my negative 1, but that's 6. So I have 35 minus 11i plus 6, because I squared is negative 1. And then so finally I get 41 minus 11i. Okay? So there, final answer. So you have some review problems like that. I only give you a couple problems you have to do using decimals to graph, so not many. It shouldn't take too long. I gave you, make sure you do 4 cases like I did. What I mean by 4 cases, a is negative and you have greater than, or a is positive, the leading coefficient is positive, you have greater than, the leading coefficient is positive, you have less than, the leading coefficient is negative, you have less than, and then the leading coefficient is negative and you have greater than. You have 4 of those, and then some complex number operations.